We're going to talk about explainable AI and application for natural hazard prediction. So, explainable AI is a very recent development in artificial intelligence where tools that are typically belonging to the family of AI, for example, deep learning in particular, that become so complex that cannot be easily interpreted, they are equipped in a post-processing manner after you generated that model to give, let's say, an interpretability level that is useful for us to trust the prediction we have made. Because normally what happens, as I mentioned before too, what happens is that in statistics, you have good performances, no doubt, and then you have, for instance, that interpretation is guaranteed. So you can really understand why a prediction is made, why probability of occurrence of a landslide is assigned to a given slope, for instance. The same thing cannot be said for deep learning architecture, where you can only use the probability you get at the end of the process. But this explainable AI is a recent branch who's trying to combine the explanatory power of statistics together with the typical performance-oriented outcome of a deep learning model, of an an artificial intelligence model, I would say.
Okay, would you say that this is, let's say, on a users trying to say, well, I don't really want to trust the machine, but I need some explanation what's...
Sure. I mean, it is also a way for us to take that output and see if it works, right? Okay, if I can understand, for example, let's make the problem easy. If I am building an explainable AI with slope stiffness and some sort of rainfall intensity, for example, okay? Simple, two characteristics. Normally the models are much more complex, but let's pretend it's just these two. So you want the probability to also follow your reasoning, your understanding of the physics behind. If I see that at larger slopes, the probability decreases instead of increasing, or at zero slopes you have high probability of landslide occurrence, then there is something wrong in there. And normally in a traditional way of doing deep learning, modeling, this level of interpretation, this level of understanding is neglected, okay? You can see whether I use the slope stiffness, whether it gives me more information compared to the rainfall or other characteristic of our landscape, which is called predictor importance. But other than that, you cannot really investigate the model anymore than that limitation. While with explainable AI, you have the ability to query element by element your model and understand, oh, look, as the slope increases, my probability of occurrence increases. As the rainfall intensity does the same, the probability does the same. So in that sense, you have you can rest your mind that you can see your assumption reflected in the outcome rather than blindly trusting the model.
Is this much more difficult to implement rather than a standard AI?
Again, it's a post-processing tool that we will perform after we have generated a neural network model. And I mean, it takes time to generate, but it doesn't make it any more difficult, I would say. It's just an additional step that will require your time, the machine time, also visualization you need to query and understand, but it is worth the time you invest for sure.
Okay, thank you very much.
Thank you.
Do you want to be a GeoHero as well? Then take the first step and click the subscribe button and then the bell button to always be the first to know when one of our GeoHeroes posts a new video.